We got words. Does this scare you? Does this scare you, have all these words, have to read? Yeah? Why is reading so scary? Because you guys are just scrolling on TikTok all day for your whole life? It was, oh, I guess when you were younger, what it was Twitter, then it was Instagram, then it was Vine, then it's TikTok. It's just a whole bunch of bullshit, right? That's all you do. You don't read, you just watch people just dance for you. That's all you do. So, what do we want to do for this problem? You love reading? You know, if you really do love reading, as a side note, I strongly suggest one of those speed reader apps. So it kind of keeps the words all focused and centered, and you never have to move your eyes, and you can read like 400, 500, 600 words an hour. It's pretty, or a minute, sorry. It's pretty quick. Anyways. So what are we looking for? So how about this? Can someone give me an expression for the exact thing that we're looking for? Like if I asked you, what is the exact concentration in sorry, if I asked you, don't use linear approximation to estimate the change, I said, find the exact change in concentration. Can someone tell me that? The exact change in concentration is what? So if I wanted to know what is the exact change in the concentration from 2 hours to 2.1 hours, wouldn't you just plug numbers in? Yeah, but what numbers and what? Give me an expression. Give me a symbolic expression that gives you the exact change in the concentration. That's what I'm asking. I'm not asking for a number. I'm asking for a symbolic expression. C of 2.1 minus C of 2. Okay. Right, the concentration at 2.1 hours minus the concentration at 2 hours. Now, how does a tangent line approximation, right? How does linear approximation fit into this? How am I going to use linear approximation to approximate this? What do you think you might do? Let me just write it neatly. So how does a linear approximation fit into this? And you might want to think about, what function, right? What tangent line are you looking for? What function would you use for your tangent line? And what would be your point of tangency, right? If you start thinking about those things, right, that might give you a hint about how you might go about getting this difference. What do you think? I see some people typing, so I'll wait a second before I give you maybe some other hint. Mohammed, I thought I saw you typing. No? No typing? You don't want to volunteer anything? Camelia, you got any thoughts about this?
Reading, I can't type.
You can't type? You can't read and you can't type? You said you can't read and you can't type. No, you can read. Okay, how about this? Here's another hint. What if I asked you, I didn't want the change in concentration. I asked you, estimate the concentration at 2.1 hours, which would be just this value. How would you go about doing that? If I asked you just that, approximate the concentration at 2.1 hours, not the change, just this single number. How would you go about doing that using a linear approximation? Think about the last two examples. How did we get tangent of pi over 4 plus 0.01? How did I get 18 to the 1/4? I used here the tangent to tan of x, right? At x equals pi over 4. Here I use the tangent to x to the 1/4 at x equals 16. Nashika, you said use a close whole number. We need a bit more than that. That's not really precise. Can we be more precise about what we're trying to do here? How would I approximate just C of 2.1? Muhammad says use the tangent to C of t at t equals 2. That seems pretty promising, right? So that would get me C of 2.1. Now let's generalize that to the difference. Well, I know that my tangent line is going to be what? My tangent line is going to be, it's y equals point slope form, y0 plus m times x minus x0. What is y0 in this case for this tangent line? Right, you go through the whole thing, right? It's the y point, but can you give me a symbolic expression for it? All right, Muhammad said find the tangent line to C of t at t equals 2. So what's going to be this value, this y0 value there? I'm looking for a symbolic expression. C of 2. That's right. It's going to be y equals C of 2 plus blah, blah, blah. And then I know that this y value is going to be the same thing as C of 2.1. So in fact, we actually see when I look at the difference, when I look at C of 2.1 minus C of 2, that's actually just going to be the other part of the tangent line. In other words, the C of 2 is already included in the equation of the tangent line. So linear approximation gets you, I mentioned this very briefly at the beginning of the lecture, linear approximation can be used to get individual values near the point of tangency, but can also be used just as easily to get differences in y values. And the nice thing about the differences in the y values is actually I don't need to calculate C of 2. But in any event, now that we kind of know what we're doing, let's actually do it. So we are going to find tangent line to C of t at t equals 2. Okay, so what is my point? It's 2 C of 2. I'm actually not even going to care about calculating C of 2 because it's going to cancel in the end anyway. We're going to see that. And what is my slope? So first of all, what is my C prime of t? Hopefully you should all be experts in calculating derivatives by now. Right? We cannot afford to have any mistakes with derivatives from now on, right? This is a basic skill that you must all have. So I use quotient rule, right? So bottom derivative top minus top derivative bottom all over the bottom squared. Right? And I can simplify this very easily. I can see I get 2t squared, negative 2t squared plus t squared. So I get 100. Let me get rid of all this. So we get 100 negative t squared plus 1 all over t squared plus 1 squared. Okay, cool. That's my C prime of t, but what is my C prime of 2? That is the actual slope of the tangent line. I get 100 negative 4 plus 1 over 4 plus 1 squared. So you work out this out, right? 100 over 25 is 4 times negative 3 gives me negative 12. Okay, so the equation of my tangent line is what? It's y equals C of 2, which I never bothered figuring out because I don't really need it, minus 12 times t minus 2. And again, in the language of the previous problem, why did I get this tangent line? So this means that if t is near 2, right, then the y value of my tangent line is approximately the y value of the original function. In other words, c of t should be approximately equal to c of 2 minus 12 times t minus 2. Really, that's what they thought I drew. Okay, there we go. All right, everyone should be good up until this point, hopefully. Right, we all know how to find tangent lines. Right, the only thing we're really adding here is a certain interpretation of the tangent line, right? That it approximates the function near the point of tangency. Now we're ready to answer the question. So now we have, recall that I wanted to find out my change in concentration, which was C of 2.1 minus C of 2. So according to my tangent line formula, notice if I can just move the C of 2 over, right? So C of t minus C of 2, I would actually just get minus 12 times 2.1 minus 2. So I get here just negative 1.2. That's it. So again, notice how I use the tangent line formula to get C of 2.1, but the C of 2s will actually end up canceling out. So I never had to calculate that number in the first place. Now, the last part of the question said, is this an increase or is it a decrease? So did the change in so did the concentration increase or decrease over this period? What would you say and why would you conclude that? Decrease. Ayana, can you say why it decreased? Decrease. The negative in front go negative 1.2, decrease because the value is negative. That's right. The delta C is negative, so therefore it decreased. Okay. So that's that.